Hey, all right. So, example 4 says, suppose you launch a water balloon from a giant slingshot. Let S of t give the distance in feet that the water balloon traveled from its initial starting point as a function of time in seconds. Explain the meaning of the derivative notation. We got two of them, ds dt when t is equal to, and then s prime. But if you're talking about the derivative of position, that's velocity. So I could say 2 seconds after the balloon is launched, the balloon is traveling at a velocity of 38 feet per second. Okay, so that's example 4. On 5, the total cost C in dollars of an airplane flight is a function of the number of passengers in that can be calculated by derivative airlines using the function C equals F of N. What does it mean to say that F prime of 182 is 58? All right, so remember the variable that we're using is the number of passengers. Okay, the cost is the 58. All right, so when the number of passengers reaches 182, the cost of a flight is increasing at a rate of $58. $58 per passenger. Because remember that because the thing that's changing is the cost, right? But it's changing with respect to the number of passengers. Okay, so whatever we're talking about here, it's always dy dx, right? So if this is our x and this is our y, then it's the change in the cost at that moment with respect to whatever this variable is, and that variable was the number of passengers. Okay, so that's 5. And we'll do